Alright, so because Apple products are terrible, this video got posted a little bit late because my iPad has cruddy storage and I couldn't figure out how to delete said storage until homeroom. So, I apologize this video got posted late, but hopefully by the time I finish this third try, I'll be able to post it. So, today, as I said yesterday, we're going to be learning some postulates and theorems that correlate with our angle pairs we learned yesterday. So the first pair is corresponding angles. We have our postulate 15, which says if you have two parallel lines that are cut by a transversal, then the corresponding angles are congruent. So here, remember the arrows being parallel. So in order for this to work, you have to have parallel lines. So two parallel lines cut by a transversal, corresponding angles are congruent. Same thing is going to be true for alternate interior angles. So again, if you have two parallel lines, alternate interior angles will be congruent as well. Alternate exterior, same thing. Again, you have to have the parallel lines. Here, angles 1 and 2 are alternate exterior, so they would be congruent. And then, same side interior are not congruent, so this is why it's important to distinguish between them. Same side interior angles are supplementary. So supplementary, if you remember from last chapter, means they add up to 180 degrees. So angles 1 and 2 add up to 180 because we have these parallel lines. Again, for all these, that hypothesis is if you have parallel lines. So the only time you can use these rules is when you have parallel lines. So here we have a diagram. We have three lines that are all parallel and two other lines. So let's find the measures of angles 1, 2, 3, 4, 5, and 6. So measure of angle 1. Now, oftentimes people will say, oh, it's 106 because these are alternate exterior angles. However, this line and this line are not parallel, so that doesn't work there. But these two are parallel, and 82 is also alternate exterior with 1. Because the lines are parallel, angle 1 is 82 degrees by alternate exterior theorem. Which means angle 2, since they're a linear pair postulate, says angle 2 would have to be 98 degrees. Measure of angle 3, well 2 and 3 are same side interior, which means they're supplementary. So if 2 is 98, 3 is 82 degrees, which you can also tell because these are vertical angles. And then finally angle 4 on that side is 82 degrees as well. Either because you can say these are alternate interior, or 3 and 4 are also corresponding, so either way. Then we move over to this side, angles 5 and angle 6. So measure of angle 5, same side interior, so supplementary. 5 is 74 degrees, and the measure of angle 6 is corresponding with 5, so that's also 74 degrees. Next, we're going to solve for x. So applying some algebra. Here, parallel lines, alternate interior. So these would equal, and x would be 101. Next we have same side interior. Hopefully you can see those okay. Same side interior are not equal, they're supplementary. So 4x plus 5 plus 3x equals 180. So 7x plus 5 equals 180. Subtraction property of equality and division property of equality. And finally, we have alternate exterior. Those are going to equal. So 27x equals 81. Division property of equality, x equals 3. Hopefully that's pretty straightforward. Now, there are two variables in here. It says work with a partner to solve for x and y. Now, you might not have a partner at home, especially if your name is Craig and you have no friends. So feel free to work individually. But if we look at this problem, which that was your cue to pause it and try to do it ahead of time and then see if you're right. So the key to this problem is we got obviously three different angles. We want to use the ones with the same variables first. So we have x's here and here. Yes, these two are equal, but one's an x, one has a y, can't solve for it yet. So you have to look at these two, they're the ones that have x. These are same side interior, meaning they're going to add to 180. So 3x plus 6 plus x minus 18 equals 180. Combine our like terms. Addition property of equality and division property of equality. X is 48. Still got to find y, so let's plug x in. Plugging x in, 48 minus 18 gives us 30 degrees. These are a linear pair, so they have to be supplementary, so this should equal 150 degrees. So if we solve that, 8y would equal 144, so y would be 18. Not too bad. And now it's time for your favorite thing, proofs. You know, I bet you like proofs just as much as you like students leaving sucker sticks on your tables. Alan? Anyway, we're going to prove the alternate interior angle theorem. So again, we're proving that theorem, so we can't use that theorem to prove it. So let's start with our diagram. We got a couple of lines. I did forget to label them. Let's call them M and N. So our given. Oh, I don't see a given written anywhere, so we got to look at our diagram. The given information is our parallel lines. So line M is parallel to line N. Given. Something you should be on the lookout by now is vertical angles. So the next step would be angle 2 is congruent to angle 3. That's our vertical angle theorem, which says vertical angles are congruent. Then for step 3, well, we're proving alternate interior. We do have the corresponding angle postulate that we can use here, which says your corresponding angles are congruent. So angle 1 is congruent to angle 3, corresponding angle postulate. And since 1 and 2 are both congruent to 3, we can now say that angle 1 is congruent to angle 2. And that would be your transitive property of congruence. 4 steps, short and sweet, and we're done. So, there's your assignment. Feel free to work on it at home. But you don't have to. You can always start working on it in class tomorrow, as you'll get most of the period to work. Hopefully, that didn't make you cringe as bad that time as my last video.